Professor Kumberger will lead the discussion, general discussion now.
Okay, so my proposal, because we are already somehow in this general discussion, I would like to ask all speakers to come to the in front of the plenum now, in order to open this general discussion in this AGI style of the conference. We will place some chairs here, and then we will have our speakers here. We are not complete yet, but yeah. Okay, I think that's the first question.
Yeah. Just continuing the topic of Kris, did you think about combining time and energy to one unit just because there's a computation time of each instruction in Turing model, which is a consumption of some energy, so you could combine both and leave just one missing part. It is time in the computation model, not both.
Sorry.
Yeah, because you said you are missing time and energy, and since the computation time of a single Turing machine instruction is some time unit, and also we can assume that single instruction is just some time of computation and some energy consumption. Could we just combine both and say that we are just missing computation time, not both time and energy?
Maybe, but probably not, because it's not tied to any physical reality. You could say, okay, we'll slap a femtosecond on each move, but it has no meaning. I mean, it's arbitrary. The whole point of science is to explain how the world operates, and if you implement computation and move it off the paper of the mathematician and implement it, it will always have an instantiation of some sort. And as far as I can tell, very little has been produced that fundamentally addresses the issue of tying computations at the level that we're interested in for AGI, at least, to a physical reality.
I will try to continue a little bit on this. If we take the first three talks into account, then one interesting thing was that these three approaches are, in my opinion, quite expressive in a certain sense. So if for example, consider Professor Xi's architecture, which is a kind of a dynamic description logic, with variables about actions, variables about axioms, and probably also including some quantification and some BDI features, where BDI, dependent on your axiomatization, is usually considered as at least something like a higher order multimodal dynamic predicate logic framework, which is extremely complicated and even not first order axiomatizable, usually, depending on which framework you choose and which axiomatization. They are all very, very expressive, and it's not even just the question to compute something in time. Perhaps some of these frameworks may be not computable at all in a certain sense, right? So we are going beyond somehow what Turing proposed. Maybe it depends on what you choose precisely, but in a certain sense, the higher order reasoning is a hard topic usually, right? And my question would be concerning, for example, all these three talks before, and this goes perhaps to all of you guys. So what is the complexity class you are talking about? We had the very expressive architecture, the CAM architecture. We had in the ontology the sumo, that was Dolce. The Dolce is also a first order representation, plus some BDI features, which could be again somehow higher order. And we had also in the sub-symbolic framework kind of a network structure, which a dynamic network structure, which if you represent this on a computational complexity level, it could be also relatively expressive. So my question goes to you three guys. So what are the complexity classes of your frameworks somehow?
Yeah, because today the time very short. Is I only focus on the formalization for the mind modeling the CAM. There are a lot of things should research and explore. In the particular for the consciousness, I think now we are for the very important project for 973. Mainly, maybe we are focused on the this global working memory theory, yeah, proposed by Baer. Yeah, so and also we are another is motivation theory is also there. So the Bach, this complexity, he did not come in. His system also very interested to develop some C modeling for the motivation theory. So this also we have the special paper to describe this. So a lot of the question, I think the left there, because here is only talk about how to use dynamic description logic to describe the memory hierarchy, like this. Yeah. Okay. So, thank you very much. Yeah.
Of the speakers so far, I am the only one who talks about the sub-symbolic models, which involves a lot of numerical computation, which involves a lot of matrix kind of calculation, which takes a lot of time if dimensions become larger. And I'm not sure how it relates to the complexity issue in the symbolic calculation, but it is also the issue of calculation time in the sub-symbolic models.
Okay, so I used the ontology called the Dolce that basically is done in first order logic, so it's not decidable. And but one thing that I want to say is that so it is first order logic, regardless the fact that it seems to introduce some higher order BDI. But with some tricks, you put everything in first order logic, you relabel the variable, you label predicates, and it's first order logic. Plus some modal reasoning in the big, if we consider the full ontology. However, there are some computationally feasible implementation in KIF and fragments of, you can translate some pieces of Dolce into fragments of description logic, and so get the complexity classes of the description logic that you need. So there is some something treatable, let's say. And there are also some recent paper that implement some parts of Dolce in Datalog, and getting some constraints on the particular database that issue. You can get a polynomial algorithm for satisfiability, but it's very narrow. So the point is that when we want to stress more on knowledge representation, then you kind of forget about complexity issue because you want the precise language, and then you try to go back to the complexity issue when you have the nice representation. That's the
Other questions? Yeah.
it strikes me that modeling emotion, as Daniel's paper represents, could be a useful abstraction for dealing with time and energy. I wonder if you agree. The idea being that, for example, with regret, if regret is reduced to recognizing a better plan than the one that was executed, by not going into a state of regret, we don't have to calculate the difference between the plan we executed and the plan we wish we had executed. If we are sure of the plan, that is, we don't have regret about what we're doing, we don't have to calculate the other possible plans and so forth. So at that point, trying to keep the system out of a state of regret becomes a way of avoiding additional time and complexity, obviously at a fairly high level of abstraction, but then it becomes useful as opposed, useful for creating thinking machines as opposed to just modeling emotional machines. Is that a fair representation or a fair way of applying what you talked about?
Yeah, I agree. I agree with this point, and I think it's interesting that you spotted this analogy between the two arguments, let's say. So I was thinking about the fact that, so what we are trying to do, I mean, not just us in our paper, but a bunch of people in behavioral game theory, is to move away from the abstract representation of the Homo economicus, that is perfectly rational, and so you want to describe real agent decisions, because if you have real agents, a good description of real agents, then you can try to make some prescription and try to understand how the system is going to evolve for real, not in the equilibrium of the game theory. But yeah, I agree with this view of regret as of this description of this new notion as something to avoid unnecessary loads somehow. Okay, thanks.
Kristen, is that an oversimplification?
Okay, that was the question that I needed to get off the chair. You have to ask, why are we formalizing emotions? And if the goal is to get a better understanding of cognition, either in the wild or some idealized version of it that strips away the unnecessary stuff that nature sort of came up with, then I think it's a very dangerous game, because the formalization is at a very high level of abstraction. And does that mean we then take this formalization and start to do psychological experiments to see if it actually expresses reality? Because if it doesn't, then it's not useful for that purpose. Okay.
So I think that the division of labor, let's say, so I think that the representation of emotions is helpful for us in order to design tools that may aid, people that has really to organize a system or something. But I don't think that in this case, at least in the work we are trying to do, representations are connected to something that we can say about reality or about science. So it's behavioral economics or neuroeconomics that tells us how emotions work, and then we do our job in order to get them into a system that may be nice to work and to design, prescription for a multi-agent system. That's the point of view of the work we were trying to present here.
So in other words, calling it emotions is just a label. You could just call it XYZ.
No, because it's we want to match the data from psychology, let's say. So they call it.
Okay, so you
emotion,
do
we have
want
that,
to map
and
it.
we want to have a faithful representation of that. But I'm not saying that I'm adding something more about their comprehension of reality.
Okay.
That's my point.
Let me follow Michael, because I'm not sure I got the answer to this question, which is.
So follow up. Hopefully you didn't already say this, but so is your model, is your formalization of emotion to create a model of emotion to understand someone else's emotion, or is it to create an agent that has emotion?
So I think that here in this work, we use the understanding and the scientific knowledge about emotion that comes from psychology. So we take this data, they know it, and we try to have a formalization that goes that can take into account this data, so that when we program an agent system, we can put in this emotion and see how the system may evolve. Let's say that's my.
So the formalization hopefully will allow you to check agent that you build sometime later to see if
Yeah.
it really has emotion.
That's the ideal goal of.
That's the idea.
yeah.
Instead of, you can just, okay.
Yeah.
Any further questions? If not, then oh yeah, there's a question. Very good.
Also a question to Daniel's proposal. So what's the point of producing a robot or AI system with emotion? Suppose there are two agents, one is without emotion, one is with emotion. Put it with, get it more emotion-like. Of course, we'll make it more human-like. But we are proposing is to get it work more efficiently. How can emotion helpful in this system?
So the example, the motivation and the example that we were putting in the paper is the following. So this is about describing these socio-technical systems that are like a multi-agent system, but in which you have some artificial agents and some human agents. And so you can imagine an airport. There's an airport with some detection system that I hope it's efficient, plus some real agent that is working within this environment. And taking into account the emotion allows us to describe this human agent behavior in the system, for example. And then we know that if this agent is regretful, is going to make riskier choices. Then we know this. We know, okay, we know it for a fact from the psychological literature. And since we know that, when we try to design the procedure, the protocols for letting agent interact in the system, we can add this information to say, oh, well, if people are in that situation, then they are going to feel regret, and then maybe they are going to make riskier choices. So maybe we can implement some procedure that prevent this to happen or can cope with this situation. That's the motivation of not designing agents that are emotionally biased, but to keep into account agents, real agents that are emotionally biased, because I mean that's a fact. Thanks.
Are there any other questions? If not, then I have a last question to all of you, and please ask for short answers. If we take into account all these emotions, so there was emotions involved, and there was this nice distinction. So we had two symbolic approaches, one sub-symbolic approach, and Kris was not so completely precise about this, but we have here a distinction. So my question would be, if you take emotions into account, and now the whole branch of emotions, not only regret, for example, and disappointment, but the whole variety of possible emotions. Do you think that you need some sub-symbolic features in any case? And this goes to all of you. Because usually that would be the natural tendency. We saw now that there are also pure symbolic approaches, at least for regret and disappointment, very explicitly. But what is your opinion on that? Whoever wants to start.
Well, even if you use symbolic approach, you need some kind of analog level of emotion. Well, I think it's agreed or not. So my question is, how do you incorporate analog representation in ontology?
No, I agree that in order to have a faithful description, you need this level. And so whereas what we presented was a way to make emotion explicit, so symbolic. So and we focused on that. So I don't know how to link the two aspects. I think it's maybe a very difficult problem. It's like how to, I don't know, maybe it's close to what was discussed in the first part of describing images and this connection between conceptual representation and learning from images.
I think that I'll answer this from a practical point, because we're still trying to build AGIs and we haven't succeeded. And so that kind of defines, in my mind, how this question should be answered. And I think that starting at the sub-symbolic level, as a way to implement a holistic system that incorporates a lot of the psychological features that we're interested in and that influence each other, that probably matter for building a proper AGI, it's a very difficult starting point. So I think starting at the symbolic level is more likely to be successful or move us faster along the path.
Okay, maybe tomorrow evening I show the system is the applications. Maybe have several demo can show how about the use the research effort for the applications. Then, for example, the cross-media, the intelligent retrieval system. Like this, we can use the this architecture and the idea to do some for the traditional image or video, the processing come together, because with this from the cognitive view, how to process the video or image. So this is cross media like this. So I think this research is we are also pay attention to the applications, not only for the fundamental theoretical.
Okay, thank you. Thanks to our speakers, thanks to the audience for this first session. I think we close this first session now, and I think we continue at 10:20 in 5 minutes break, and we will continue at 10:20 with a session on formalization and modeling. Thank you very much.